right? That's good enough, I guess. Right, that's working. Cool. Good morning. Do you think with a speaker or without a speaker? Like, do you really want a lot of Sam this morning or no Sam this morning? No mic? Or like, shall I go grab a real mic? And then just kind of, and then I'll show you my new stand-up routine. Okay, maybe that was a bad idea. I don't know. Can I tell you? Huh? I like when I can only just about hear you, Sam, not when. Turned off. Oh, this is funny. I forgot this was like this. It's like, all right. So what's the lecture for today? Prototypes in JS. The goal for this lecture is prototypes in JS. The teacher note is to do. So, what do you want to talk about? What do you want to learn about? Prototypes, clearly. Okay, what's a prototype? A what? It's a blueprint. That's interesting. Where have we heard blueprint before? Classes. Where have we heard about classes before? Object-oriented programming or something, right? Let's take a look at classes. All right, today we will be talking about prototypes. End goal for today is I want you to be able to answer this question: how does property lookup work in JavaScript? Let's start by taking a look at classes. So we're going to need a ton of examples today. Who wants to start? Who wants? What kind of class should we make? Okay, so this is going to be for dogs. Dogs.js. All right, how do I create a class for dogs? You've ruined it for me. All right, so we got a dog class. Do I have to make a constructor? But I could make a constructor. What does a constructor allow me to do? Whoa, just talk about inheritance. So constructors don't actually have anything to do with inheritance out of the gate. So this constructor will get called when I create a new instance of dog. So this allows us to do any kind of setup code, setup, which is usually setting up properties, right? Like, what would a dog have by default? Sure, this dot fur equals what's like the default value for every dog on fur, like just true or? This Genital. How do you spell genital?
Now that's true or false, for sure.
We're gonna figure this out the old-fashioned way by putting it into Google. Oh, it's genitals. Genitals, not genitals. We could turn this into an emoji and it would get awkward quickly. So let's just make it, yeah. By default, they have them, I guess. You know what? This could be passed into the constructor. So at the moment that we create a new instance of dog, we actually get to set up some default parameters. When we create a new dog, we will make sure that we specify genitals. This got bad quickly. Usually it doesn't take, like, this 8 minutes into lecture. Good job. All right. Okay, so fur will default to true, and genitals will be whatever we pass in. Okay, so how do I create a new instance of dog? What should we call our first dog? What did you say? Pat? Yeah, exactly. Pat the dog. Poodle. Pat Poodle. Poodle Pat? Poodle Pat. That's his name. Her name? Who knows? Doesn't have genitals. We can't tell. Sorry. Equals new dog. It's a good thing. We don't want too many stray poodle pats. Okay, wow. What is new? What is this word, though? Why is it so special? Why does it get highlighted weird, and why does it just, like, there? Hey, what? Yeah, in most object-oriented languages, we use the new operator to create a new instance of an object based on a class. Meaning PoodlePat should get all the behaviors and all the state that the class kind of defines, as if it were a blueprint. So PoodlePat should, in fact, have a fur property and a genitals property. Let's just console log these out, because why not? All right. Is this going to work if I run this? Have we written this correctly? I think so. Let's open up a terminal window. It's always fun to switch between screens. Okay. Node dogs? Dog. So, PoodlePat, true, has fur but does not have genitals. Cool. Okay, what else can we do with classes? Let's play around with this a little bit. Okay. What does a method do with a class? If we define a method within the class, we get to instantiate that method on any instance of an object created from that class. We use methods to define behavior. So what kind of behavior would a dog have? Bark. Bud, bark. All bark do. Oh, a woof or a yip? Oh, a boof or a yip. Console log boof or yip. Sweet. Okay, so now my PoodlePat should, in fact, be able to bark. Boof or yip. Nice. What else can we do with classes? What? You're just talking about genitals back there? Come on, this is a serious lecture about prototypes. Yeah, all right, so let's create a subclass or a superclass. All right, what's our superclass of dog? What makes it so super? What? Mastiff?
Yeah, that's a type of dog.
Oh! Either way, I'll let you decide. Super or sub? Ooh, laser dog. extends dog, obviously. Let's put this underneath so it's kind of a little bit more logical. We have our dog class, then we have our subclass of dog, laser dog. All right, what's significant about a laser dog? Shoot lasers. It's funny. I did an iOS lecture once where we literally set up a laser and shot lasers. So we could make a laser dog in like an advanced lecture where we actually get a laser in the room and attach it to a dog. We have dogs and we have lasers. We could do that. And we could code it in JavaScript. And that's the important thing. What do shoot lasers do? It what? Pew pews. Wait, but like in a higher pitched voice, right? Like pew pew. Okay, so can Poodle Pat shoot lasers?
No.
Why not?
He's a regular dog.
Okay, so how do I make Poodle Pat a laser dog? I can make him a laser dog. Do I have to change anything else? Will all of this work? I mean, laser dog doesn't have a constructor where I'm passing in false. It doesn't have fur. It doesn't have genitals. It doesn't have a bark method. It does have shoot lasers. Will all of this still work? Exactly the same.
Yes.
Yes? All right, let's test it out. Yeah. What happens when we create a superclass or a subclass, we get to basically extend all the behavior of the original class. So laser dog is dog, but we can add stuff to it. But it is, by default, what we extend. So every time you created your React component, you had everything that came with a default React component, and then you just got to add your own stuff on top of that. So everything else remains the same. So let's kind of leave our dogs alone for now. In languages, most languages that have classes, the class can be considered a blueprint. So think of that for a moment. Think about a real blueprint for a building. What are they used for? To make similar buildings. They kind of give you almost instructions on how the building should be built, details about like what goes where. And that's what a class should be. It should just be kind of instructions on how to construct a new thing, details about what the new thing will be, and it gives you the ability to create multiple versions of this thing. So if you had a blueprint for a house, it create multiple houses that are all have the same like default behavior, default look, default instructions on how to build them. Yeah, does anyone have any questions about that? That kind of process of creating this class, this thing that is just kind of this blueprint, and then using that to create the real thing. So think about that in the real world. A blueprint is not super powerful, not super useful, except to create the thing, right? You can't live in a blueprint, but you could live in the house. So blueprints by themselves kind of useless, but the thing you create from them, pretty useful. This is how classes are supposed to work. In JavaScript, though, there is no such thing as a class, and it all works a little bit differently. How does it actually work in JavaScript? Prototypes. Does no one want to like argue with me? I just said there's no such thing as classes, but I've written class at least twice. There are no such thing as classes in JavaScript. I mean, even using classes all week, right, in React? Okay, so classes might just be syntactic sugar. Should I be taking notes about this stuff? Maybe. I'm going to write that down. Classes don't exist in JavaScript. They exist in JavaScript. They are syntactic sugar. Spelled that right? Yes. What does syntactic sugar mean? There was a quiz about this? Yeah, kind of. We don't have a remote cohort, right? Okay, there's not like people in Victoria like, what the hell, what's going on? They can, whatever. Yeah, like, wait a minute, genitals. Where's, oh, hey, it's Sam, few students, here's the stream, boom. Okay, I do have 2 links on my notes page already. The first one is to the function.
Good Monday morning.
That's all I wanted this morning. All right, this is a video series. There are 7 videos. If you want to learn all about object creation in JavaScript, I suggest watching this. If you want to get a little bit more advanced with JavaScript at any point, the You Don't Know JS series is really good. This is the book on objects and prototypes and stuff and goes into so much detail about how JavaScript works. If this lecture interests you, or you missed the lecture. Okay, so classes don't exist in JavaScript. They are syntactic sugar. So JavaScript works without classes. Everything that we can do with classes, we can do without classes. But still, classes were added to the language, like this class word, even though it just kind of wraps around what JavaScript already does. Does anyone know why this was added, even though it's kind of like this weird addition that doesn't do what it does in other languages?
You want object-oriented programming?
To look like other object-oriented languages, that's the only reason. I would say it's not easier. Object-oriented programming you can do in JavaScript without classes easily. It's you have more power, more control. It's because people came from other languages like Ruby or C++ or C# or Swift or whatever, and they came into JavaScript and they looked for the class keyword because that's how you start programming in those languages. Like if you want to create an object in Ruby, you create a class and then create a new instance of that class. If you want to create an object in JavaScript, how do you do it? You just like create a new object, right? You don't need a class. JavaScript's really cool like that. You just create objects. But people came to JavaScript. They didn't know that. They looked for the class keyword. They got upset when they couldn't find it. And then after years of complaining, the JavaScript community finally added the classes to the language. So classes don't actually exist. It's just syntactic sugar around what JavaScript actually does, which is prototypes. And prototypes just have to do with ordinary object literals, kind of like week 1 of bootcamp when we just played around with objects and functions. It's kind of like that. It's just as simple as that, and this kind of overcomplicates it. So, are there any questions, or you want me to go over any of that before we kind of dive into how prototypes work? Yo. Classes are supposed to help us program in an object-oriented way. Object-oriented programming is supposed to help us with modularity. You do not need classes. Unless the language says you need classes, like Ruby, where you need a class before you can create an object. But in JavaScript, you can get all the modularity, all the benefits of object-oriented programming without using classes. With objects. Because, I mean, that's what object-oriented programming is all about. It's objects, right? Not classes. Classes are just sometimes a tool we use to create the objects. No. I'd have to change the syntax a little bit more. What is a class under the hood? What is, let's console log this, what is type of dog? What is it? It's a function. Yeah, classes are actually functions. And it gets weird. So if we were to, let's see. It just, yeah. So much more simple than it needs to be. I'm now console logging the dog that we created from the class. And it's a laser dog. It has fur and it has genitals, but it doesn't have any of those methods. I mean, it has the property. It doesn't actually have them. But it doesn't have any of those methods. It doesn't have shoot lasers or bark. So where are those methods stored? Yeah, they're stored in dog.prototype. Oh wait, no, they're stored in dog.prototype.proto? No, I got it wrong. I don't know. We'll get into it and we'll figure out where I went wrong there. Huh? Oh wait, I think they're it's an even weirder thing. Object.getOwnPropertyNames. This isn't right. We're going to move on and stop concentrating on it. There we go. Constructor and bark. Those are both methods of dog. dog.prototype. Anyway, just kind of wanted to show you that it's all a little bit weird, but it doesn't have to be. So, now that you're nicely confused, yeah, it's a little bit weird, but it doesn't have to be. You know JavaScript's weird, right? Everyone knows that, or do I have to like convince people that JavaScript's weird? You're just like, yeah, I guess. I mean, even if you didn't know other languages, there's just like some weird things that happen with JavaScript, which I sometimes like show to people. Like, you know, what happens if you try and add a number to an array with a number in it? Like, what should logically happen in this case? I don't know, maybe you should get an error saying you can't add a number to an array, maybe. Or maybe, you know, let's convert them both to strings and give you the number 10. Right, like, thanks, JavaScript. Just weird stuff. Let's see if I can get this right. B plus A plus 1 minus A plus A. Yeah! Right? Little tricks. Right, exactly. Yeah. Just fun things. Works with JavaScript because if you try and add something, it's always just going to turn it into a string. So you got like a nan in there, that's cool, just turn it into a string. Okay, I digressed. Back to objects. Okay, so we're done with classes for the moment. Let's create an object. What object should we make? Avocado.js is the file, and we're going to create an avocado. Just like week 1. Right now, we're only going to deal with objects and functions. Yeah. So, what should we give to our avocado? Should that be like a function or a property? It could be like, okay. So you got like age, right, in days or something. Maybe I'll just say days old. Days old, okay. And let's say that defaults to 0. And then we have a method that's like is ripe. And it's like, okay, let's do this in, okay, so if, how many days, when is the avocado ripe? If it's 3 days old, return, eat it. If this dot days old is less than 3, return not yet too hard. And then otherwise we'll just return gross. Cool. That's what avocados do, right? What else can we give to an avocado? Oh, that's probably good enough for now. Country of origin. Of origin. Yeah, sure, what's that going to be? Mexico. I think that's where all the avocados in Canada come from. Close enough. Okay, so if I want to, I don't know, console log the days old of the avocado, how do I do that? Avocado.daysold, throw that into a, whoops. Damn it. Console log. How do I check if it's ripe? No surprises there. Let's do one more thing. All right, so we check if it's ripe. Ooh. I'm getting excited now. These are always fun. Okay, so we're going to set interval. Console log avocado is ripe. We're going to do this every second, and every second we're going to increase its days old. So at some point, we're going to actually get back if it's ripe or not. It's going to be fun. Is everyone having as much fun as I am? Okay. First of all, any questions about the code that I've just written? Got a object literal that has a property days old, a property that is a function called isRipe, whoops, and a function or a property called country of origin. 2 bits of state, 1 bit of behavior, console logging the days old, console logging the return value of isRipe, and then the set interval is just increasing its age while console logging isRipe. Oh, we'll keep going forever. That's fine, though. Yeah, I mean, avocados don't stop aging, right? You know, it's like, do we ever stop aging? I mean, we die, but like, do we ever stop aging? It's a deep question. I could. I don't know. I'm not going to. I think it's more fun this way. Yeah. Just gonna keep adding 1 to it. Cool. Sweet. Let's run it. Did I get this right? What did I call it? Avocado. Hmm? Yeah. I mean, it's not like it's getting younger. It's only getting grosser. So this is accurate.
You should have one at like 12 days and throw it out.
Yeah, like.
Fill in your fridge.
Yeah. Okay. Okay. Any questions about that? Okay. I will get rid of this. Maybe we'll get rid of it. I don't know. We'll comment this out. We might come back to it. We'll see. Okay. So let's. Is it still going? Yeah. We'll just let that keep going. Let's create another object. Let's create an object not too related to avocado. Pickles? We're getting foodie. Pickles equals object. What does a pickle have? Type. I don't know. We're going to go dill because I know that. Brand. Brand is crunchy. Cool. Is crunchy a brand? I don't think so. Yeah. I feel like this isn't going to be as funny now because they're both foods. Yeah, let's do something else as well. I don't know, we got pickles, or I guess it would be pickle because it's a single thing. Avocado. What? Octopus? Octocat. What does an octocat have? Tentacles. 5. Is that not how you spell tentacles? Is it like tentacles? Is it like genitals? Yes. Octocat. Octocat. All right. Octo. Oh, that's obviously not a word. All right. What else does an octocat have? Do some behavior. What can an octocat do? We code really fast because it has 5 arms, tentacles, I guess. Wait, but it has no fingers, so it's like having 1 hand. If you had 5 tentacles, would it be like having 1 hand? And if you had 10 tentacles, it would be like 2 hands. Yeah. Ah, things you don't think about. I guess you only need 9 though, because what do you use your thumbs for? Yeah, but you only need you don't need the spacebar with 2 thumbs, so you could program fine with just right. Just use. Yeah, I mean, we're coding. We're not picking up stuff. We'll program something to pick stuff up for us. Everyone today just program like this all day. See how much you get done. Be great. That should be a cool rule. If you're typing code, you're only allowed to do it with 2 fingers, but if you're doing like a whiteboard or something, you're allowed to do it just normally. So everyone will just end up programming on whiteboards today. Be a fun exercise, maybe. What was the behavior we had? No. I don't know. Let's tell it to code. What would happen if you told an octocat to code? I feel like it would. What would an octocat code though? Like, what would if you like octocat go code now? What would it code?
It would just get scared.
See, is there an ink emoji? There is. Look with an ink. Yeah. Ink. Squid. Oh, there's a squid. Okay, so when you tell octocat to code, it returns a squid. Glad we're all on board. Okay, so now let's do some octocat stuff. Let's console log octocat dot code. Boom. Make sense? See? Okay, so we got our avocado, we're console logging days old is ripe, and then we've got octocat and we're console logging code. So we'll get like 3 console logs, it'll probably be 0, oh, it's still going. 0, not yet too hard, and then squid. Yes. Okay. Cool. Any questions about any of that? Oh, just dealing with objects, right? This is basic stuff. Like, come on, Sam, we did this in week 1, right? Yeah, cool. Okay, what happens now if I check if the octocat is ripe? What's going to happen if I check if the octocat is ripe? Octocat clearly doesn't have a ripe method. Avocado does, but octocat doesn't. So what happens if I check if an octocat is ripe? Any guesses? It'll be gross. Get an error message saying ripe is undefined. We'll get probably an error message saying ripe is not a function. That would make sense because ripe is not a function, it's undefined. Yeah, any other guesses? Will this work? Will it tell me that it's gross or good or too hard? Yeah, octocat doesn't have a ripe function. What are you thinking, Sam? Of course. Yeah, look, octocat ripe is not a function. Well, that was predictable. Okay, so what happened there? Yeah, but what happened there? How does property lookup work in JavaScript? And then what happened? Gave up on me. So JavaScript like went to octocat and was like, hey, do you have a ripe method? And octocat was like, nah, I don't have a ripe method, I'm an octocat. And then it just gave up. But it didn't just give up. It tried a couple more things and then gave up. What did it do? Anyone know what it did? It did not go to global scope. It checked the prototype. What does that mean? It checked the octocat's prototype. I wouldn't think. If what? One more time? Okay. So what JavaScript will do is it will go to the object. It will see if there's that property there. If it's not, if that object does not have that property, it's going to go to that object's prototype and check if the object's prototype has that property. And if that object doesn't have it, it will check its prototype and so on and so on. Eventually you end up at null, and then you try calling the method on null, and you get the fun octocat.ripe is not a function, right? Everyone's seen that error message. So how do we tell octocat that its prototype should be avocado so we can check if an octocat is ripe? Wait, can we do that? Did what I just say make sense? So if I do this little trick, object.set prototype of Let's see, the object to change its prototype. So we're going to set octocat's prototype to be avocado. And then move this up here. Now what's going to happen if I check if octocat is ripe? So now it's a function but doesn't have what it needs. What does it need? Okay, so that method needs the value days old. So JavaScript's going to be like, okay, octocat, do you have a days old method or property? And octocat's going to be like, no, you want to check with my prototype avocado? Hey, avocado, do you have a days old property? Avocado's like, yeah, sure, you can use mine. Let's see what happens. Is octocat ripe? Whoops, did I not do that correctly? Avocado is ripe. It's because it is ripe, not ripe. Whoops, that kind of made everything fail. Just make sure it still doesn't work with is ripe. It does not work with is ripe. Now we make it the prototype. There we go. So octocat, let's just really make this explicit. Octocat is not ripe yet, it's too hard. Well, so the default way of thinking, especially when coming from other languages, is to think that the object kind of like inherited all of its things from this other thing, right? Or like it obtained all of these bits of state and functionality. But that's not at all what's going on. Instead, what's going on is prototypes. Maybe I'm going to draw this out on the board. Does anyone care about the pizza selections from last night? No? So let's think about all of us as JavaScript objects. Who wants to be my prototype? Okay, I got one take for my prototype. Now you need a prototype. Get yourself a prototype. You need a prototype. Okay. Do you want a prototype? Who's your prototype? Okay. Who's Brennan's prototype? Ooh, Ken. What do you think would happen if you tried to do that? Yeah, like would the internet explode? Let's see, if we try and make a cycle, this is a cycle where it's like this thing's prototype is this, but this prototype is this. This is like totally valid and legal and not difficult to implement, but JavaScript was like, nah, let's not implement that, and it doesn't want to deal with cycles. So your JavaScript app will not even run, it will crash before it even compiles if you try to do that. So no, you cannot do that. All right, we should probably stop there. Okay, so now I need someone else. Anyone, ask me for something. It's great. Prototype that. Okay, Rosie would ask me for the marker, and I would say, cool, Rosie. Fuck. This lecture got out of hand quickly. I mean, if it would teach you all JavaScript, maybe I'll give you my baby. Okay, so I get asked for my marker. I have a marker, so yeah, here you go. Here's my marker. I have been called normal looking. All right, you asked me for my baby. Okay. I unfortunately do not have a baby on me, so no baby, but I'm not just going to stop there. I'm not going to crash. I'm going to try and help you out. I'm going to go to my prototype. Hey, do you have a baby? No? Okay, so what do you do if you don't have a baby? Is that the end of the line? All right, so then you end up asking null, and obviously you can't ask null for anything. So then JavaScript crashes. However, if any point during that chain of prototypes someone had a baby, then who else? Then Lane could have used that baby, or I guess could have used that baby as if it was my own baby. So that's what happens when you let the students pick the examples. Okay, any questions? Jeez. All right. So let's see what's going on here. We have an avocado. Okay. Avocado. Wait, I want to write this the other way around. We have an octocat. Octo, and we have an avo. And they're both objects. Like my curly braces. They're just objects. Just plain old objects. And in that example, we were all just plain old JavaScript objects. Nothing fancy, just objects. So, Octo has, what does Octo have? Tentacles. I'm just going to do single letters from now on because it's easier. An avocado has the right thing. Immediately lied. So, if we connect octocat to avocado in a way that sets avocado as Octo's prototype, then it's just setting it up that if you ask Octo for something that it doesn't have, it's going to go onto its prototype. So I'm going to just draw this as P for prototype, because that is actually the syntax prototype that I don't want to get confused with. The biggest mistake I make in this lecture is saying prototype too much, so I apologize in advance for that. So if we set octocat's prototype to be avocado, then it's always going to check with avocado when it doesn't have a property that is asked for, that it is asked for. Learning about prototypes? You missed all the good stuff. Now that he's here, you gotta do better than genitals. Oh, yeah, now I've lost my train of thought. No, okay. Right, okay. So it keeps going. Avocado has its own prototype. Every object has a prototype. And every time it's asked for something that it doesn't have, it's going to check with its prototype. Until it gets to the end of the line. What is the last thing in the prototype chain? We call it a prototype chain. Null is the very, very last thing. I'm just going to write null under here. And once we get there, you know, we can't have any properties on null, so that's literally the end of it. Does anyone know what the object before null usually is? Object.prototype. Yeah, that's what you said, right? Obj.prototype. Prototype. What is object.prototype? Using that inherit word again. It's not really inheritance. There is this thing, dot prototype, that we'll get into in a little bit after the break. But yeah, there's this object.prototype. And what is object.prototype? Well, let's say I have my octocat, and we know that its prototype is avocado, so we can, in fact, call things like isRipe. We can access things like days old. We can access country of origin. That's actually kind of funny. What's the actual country of origin of an octocat? Nebraska. Feels like a country. Whatever. This isn't a geography lesson. I'll let you say anything as a country. But octocat doesn't have a country of origin by default. So instead, it's going to look and ask its prototype, hey, do you have a country of origin? Can I use yours? And of course, avocado does have a country of origin. It's Mexico. So octocat's just like, yeah, thanks, buddy. I'm going to use your country of origin. There's no inheritance going on. There's no, what's it called? Octocat doesn't obtain any new things. It doesn't get new behavior. It doesn't get new state. It's literally just kind of passing on the message to its prototype, which is just another object. It's a very linear structure. It's just a chain of objects. So that's all that's going on there. Notice, or maybe you've already noticed this, if I create a brand new object, empty object, has no methods, no properties, can I call any methods or access any properties on this object? Well, arrays have .length, right? They are a special object that have these special, not special object. It is an object that has already had properties added to it. But like just a plain old object literal, like if you console logged array, you'd see a bunch of things. But I'm talking about like the most basic of data structures. If I console log object, it's going to be an empty object. Let's see. Whoops. Yeah, there we go. Empty object. This is the most basic thing. Can't get more basic than an object. Empty object. What is something that I can call this? I can't call .length. Objects don't have length. Are there any properties I can access on this thing by default? Not prototype. There is this double under proto thing. Talk a little bit more about that later. Like that's the logical way of thinking. Yeah, you could add stuff to it, but it's an empty object. What could you what could it possibly have? Has anyone ever called toString on an object? Knowing what we know, should this crash my app or should I get object? Potentially that'd be a good guess, but that would mean that there is a toString method on this object. Call instance of. Are there any other things? Object. So what happens when you convert an object to a string or use the toString method on an object? This is the default implementation of that. Where's that behavior live? Where's that coming from? That would kind of make sense. Because how does property lookup work in JavaScript? We go to the object, we ask, hey, do you have a toString method? The object says, no, obviously not. Like, we just created it. So then where does JavaScript look? The prototype daisy chain. What is object's prototype? What is obj's prototype? If we create a brand new empty object, by default, what is its prototype? And then what's object.prototype's prototype? Yes. Okay. So by default, this object's prototype is object.prototype, and I can access this in a really nasty looking way. Proto. This property right here exists on every object, and it points to that object's prototype. So this object's prototype, if we console log it, we'll see is actually another empty object, which is fun. But it is in fact object.prototype, which we'll talk about in a little bit more detail later. So the object's prototype is object.prototype. You can see why I'd say prototype a little bit too much in this lecture. When I'm talking about the idea of the prototype, I'm going to write it like this. When you're talking about an object's prototype, it's this property. And when you're talking about this weird .prototype thing that exists on these things, it's .prototype. JavaScript's a bit of a mess sometimes. We'll clear it up a little bit later on. But yeah, the object's prototype will be object.prototype. Let's see. Yes, that is in fact true. If I take object.prototype and console log the own property names, I have to do it this way because objects.prototype's properties are hidden so that they don't show up when you do like a for in loop, right? It's a thing called enumerable properties, which we're not going to talk about. But you can hide properties by default so they wouldn't show up when you use the in keyword, which is handy because you wouldn't want toString showing up every time you loop through an object. But anyway, you can use this property to view them, this method to view them. So this is going to show us all the methods in object.prototype, all the properties in object.prototype. So everything in here everything can be accessed on any object in JavaScript by default. Even if you just create a brand new object literal with nothing in it, you can still say .constructor, .define getter, define setter, has own property, is prototype of, property is enumerable, toString, value of, local string, and the proto. All accessible on objects by default because they exist on object.prototype, which is an object's prototype by default. JavaScript. What's that? Oh, okay. Yep. Yep. Which are not prototypes. They're just named badly. We'll talk about that. Yeah, the object, the dot prototype thing is not words. It's like trying to explain this, and you're like saying this instead of this, and it's this is another. Anyway, I'm gonna stop talking. We'll talk about this in a moment. Are there any questions about that basic concept? How does property lookup work in JavaScript? Yes. No, definitely not. You cannot have a cycle. Cannot have a cycle. So it has to be very linear. Can never loop back on itself. But it can be as long as you want it to be. Everything that classes do can be achieved using object literals and prototypes. I can do even more writing code this way. I have more power, more control, more things I can do just creating objects than I can with classes. And they're like pretty basic to use. They're just objects. So under the hood, this is what's going on. You do not need classes. Classes, in fact, don't even exist. It's just objects linked to other objects. That's what prototypes are. Objects linked to other objects. Yeah. Set prototype. Yeah, you have to. There are many ways of doing this. Is one way, but you have to make sure this object's prototype is that object. One way of accomplishing that. Yeah. No. No, because usually you don't want this big chain of events. Like a small chain is fine. Usually you want to kind of adapt composition, which is beyond today's lecture. Yeah, if you're chaining up too much, and it's a similar concept in classical inheritance model, if you're subclassing a lot, or if you're adding too many prototypes to the chain, you're probably doing something a little bit wrong, so they wouldn't get super long, hopefully. Cool. I think there was one more thing I wanted to say, and I've forgotten what it is. Oh, yeah, there is one more thing. So if we know prototype chain works this way, and by default every object ends up at object.prototype, if I wanted to add a property to every single object that ever gets created in my JavaScript app, where would I put that property? By default, I want every object to be able to use this. Yeah, so like what happens if I say object.prototype, I don't know, someone give me a good method name. Doesn't have to be about genitals. All right. What kind of behavior is Nebraska? How do you spell Nebraska? Nebraska? Nebraska. Yeah, it's good enough. It's fine. I don't think anyone in Nebraska cares. We're going to make this a method. What does it do? What does Nebraska do? Yeah, it's just console. Makes you cold and miserable, whatever. Cool, everyone happy with that? So, by default, I should be able to create brand new object, no behavior, and call dot Nebraska on it. Right? Why is it complaining? Is that a linting thing? Whatever. Ah, really? Come on, JavaScript. Okay, still just creating a brand new object, but I wrapped it in parentheses so JavaScript wouldn't complain. Cannot read Nebraska of undefined. Okay, JavaScript thinks I'm creating new block scope rather than actually creating an object, so now I actually have to... Well, I've already got my object. Let's just do it on this thing. Object Nebraska. There we go. Makes you cold and miserable. Could also, like, create a string and call that. I could also create a number and call that. What are other objects? Create an array. What are other things we create in JavaScript? Strings, arrays, booleans, true.Nebraska. Everything now has this method because we did this dumb thing. And every single time it makes you cold and miserable. What? Miserable, yes. Makes you cold and miserable.
Miserable?
There we go. It's Nebraska makes you. No, it's Nebraska. Nebraska makes you cold and... Yeah, I don't know. It's been... This is the most normal part of the morning. Okay. Any questions about anything we've gone over so far? No. Is everyone somewhat comfortable to answer the question, how does property lookup work in JavaScript? You can answer it in one word, or you could answer it in a description like that. Actually, if you ask that in an interview, you should tell everyone in the interview room to stand up and be like, all right, we're all going to be objects. You're my prototype here. Now ask for my baby. All right. All right, let's take a break. Oh, let's take 10 minutes. Okay. All right. Conjoined.
So actually, for the first half of your life, you have to do that.
Oh, that would be great. Yeah, we we switch every 10 years. I'm now. This is the peak bit. I'm now shrinking. And she's growing.
You always grow into the other.
Yeah. Soon I get to be carried around. Anyway. Is that cool? I gotta wait. Yeah, you can. Everyone read that? Oh yeah, look, I was pretty proud of this trick. I thought of this on the spot for a lecture a couple weeks ago where I had a Raspberry Pi and I had to show it to people. So I opened up FaceTime because it's on my screen, right? And then the camera points at me if FaceTime ever opens. Wow, that is slow. Okay. What is a Raspberry Pi? It's a pie made out of raspberries. Really delicious. Oh, it's mirrored. Damn it. But isn't that genius, right? I was like, yeah.
Tell us more about 604-331-420.
Yeah. So I have like 0 friends. Okay. So I get called by 2 people, my mom and my girlfriend. Every other number in here is a spam call.
Oh my God! Please tell me it's the Canadian government.
It's the Canadian, you know, it's the government. It's what's it called? The CRA. It's Chinese ones now. I got one that sounded a bit Russian. I don't know. All right.
Oh, they caught that?
Okay, who wants to talk about prototypes? Let's see where this goes. Let's see how many times I can say prototype in the next half an hour. Let's clear up some terminology. So, prototype. Whoa, prototype written like this. Let's do this with bullets. Prototype written like this is an object's prototype. That didn't do a really good job clearing that up, is it? Like, if I write it like this, I'm talking about an object's prototype, like the idea of the prototype. Like, this object's square bracket, prototype is that object. Like, Octocat's square bracket, prototype is avocado. Got it? Like, this object's prototype is this one. So I'll write it like that. Underscore, proto, underscore, which I will just call proto, is a way of accessing an object's prototype, okay? So every object has a prototype, and we can access it by going object dot underscore proto. We can access it in a bunch of other ways, but you will see this one used. It's not the preferred way, but it's the shortest, so you see it a lot of the time. And then we have dot prototype. This is a method that exists on all functions. No, not a method, sorry, a property. A property that exists on all functions that, okay, I'm going to say this and then regret what I'm saying. It's a property that exists on all functions that becomes an object's prototype when you create the object using that function as a constructor function. Let's look at an example. Let's look at an example. Dot prototype is a property that exists on all functions. It is not a function's prototype. It is not that function's prototype. It's just a property that exists on all functions. Anytime you see something dot prototype, the thing to the left of it is a function. Okay, so with that in mind, let's look at some functions. So, Yeah, let's create a function. Who's got a good function name, a good noun? And everyone goes silent. What? Eat is not a noun. Baby and pie?
Baby pie.
Like a pie for babies or a pie made out of babies? Oh, you're thinking about math. I thought you said meth, and I was like, this is getting
I was thinking about that.
baby pie? Oh, like 3.14, but baby. What would that be? Pie.js. Like, no, I wasn't saying pie. I was saying, let's screw this lecture. Let's eat some pie. Wait, you mean like? I don't know. Let's see where this goes. Function PIE. Okay. What's weird about these functions, the way I've written these functions? I've put a capital letter there. Why did I do that? What does this affect the function anyway? Does this alter what the function is in any way? Absolutely not. I just named it weird. Okay. Now, what happens if I call, I don't know, one of these functions, pi? And let's create a variable. I'm going to call it pi. What happens if I do this? What's that? The function, or when I call the variable pi, it won't invoke the function. The function only gets invoked on line 9. So, a more concrete question, what is pi? What is small pi? It's not the function. Pi is the function. When you invoke a function, what do you get out of it? It doesn't hold the function. What happens when we call a function? Huh? It's not an instance of the function. It's way more simple than that. Okay, yeah, that's probably the most accurate so far. The function gets invoked, and this is whatever the function gives back to you. What do functions give back to you? Yeah, right, the return value of the function. When you invoke a function, you get the return value of that function. What's the return value of pi? Yeah. Right now, nothing. How does JavaScript represent nothing? Yeah, it has those two ways. JavaScript defaults to undefined, but we can also represent nothing using null. But yeah, so pi is most likely going to be undefined because nothing gets returned here. Every function returns, by default they return undefined. Maybe I'll change this actually. That's a type of pie, like raspberry. Or does anyone have a better kind of pie? Pekin. That's a good pie. Strawberry rhubarb, pumpkin, pecan. I love how it knows camel casing. So it's like you spelled this part and this part wrong, but everything else is solid. So, okay, so I console log that. We're expecting undefined node. What did I call this? Pi. Undefined. Yay. Okay. Any questions about that? Yeah, I haven't done anything special here. This is like week 1 stuff again, just functions. JavaScript though introduced this operator that looks like this, which changes everything. Now, what is strawberry, rhubarb, pumpkin, pecan? It's not the function. It's what? Yeah, like you might want to think of it as like it's an instance of pi, because if I ignore all of this stuff, it kind of looks like I'm creating an instance of a class, and that's what people wanted it to look like. They're like, well, back before classes, JavaScript doesn't have classes, so let's abuse functions and make it look like it has classes. We don't get an instance of pi because we don't get instances of classes in JavaScript. That doesn't happen. We just have objects linked to other objects, and that's kind of it. Objects linked to other objects. So let's just console log this out and see what happens. We do get an empty object, and it does know that it was created using the function pi. But we get an empty object. Get an empty object. So when we use the new word with a function, some things happen. The function creates a new empty object. Empty object. Okay? That object basically gets returned at the end of the function. And a few other things, but by calling pi with new, a brand new empty object gets created, and then that object gets returned. So strawberry, rhubarb, pumpkin, pecan becomes a new empty object. Any questions so far? Okay. Another thing happens. The new empty object is accessible inside this function. How do you spell accessible? Thank you. The new empty object is accessible inside this function. So within this function, I can actually manipulate what will end up being this object. The empty object is created, it gets returned at the end, but I can also manipulate it. So for example, strawberry, rhubarb, pumpkin pie, pecan, whatever, is created using new. So inside this function, I could actually manipulate what that is. I could give it a name or a heat or whatever property or method or anything that we want to give it from within this function. So it does allow us a little bit of convenience there. Does anyone know how I access this new empty object from within this function? Let's say I wanted to give it a like dot. What would be a good thing to give to a pie by default? Crust. Let's say I wanted to do like dot crust equals flaky. Crusty. The crust is crusty. Right, I want every object that is created using the new operator with this function to have a crust that is crusty. So does anyone know, anyone guess how I access the new empty object from within the function when it's invoked using the new operator? This? So you think this? Any other guesses? Who thinks this will work? Rosie, you should at least raise your hand. Who thinks it won't work? Okay, who didn't raise their hand? Yeah, everyone raise your hand now because you didn't raise your hand. Oh, this is, you guys, come on. Yeah, right? Like, you don't even want to commit to whatever. Anyway, we can play this game, right? What does this evaluate to in this function? What is this? Okay, so if a function is invoked using the new operator, this becomes the new empty object that was created. It is accessible using this. Okay. If I didn't invoke pi with the new operator, what is this? Kind of as a side question, what does this default to in any function when we don't use the new operator? Who's been reading their JavaScript docs? The prototype, the global object. By default, if you create a function and it's just in the normal standard scope, this will evaluate to the global object. So if we happen to call pi without the new operator, we would attach crust to the global object, which wouldn't be good. So as soon as I start treating a function as a constructor function, so they're called, I identify it as a constructor function by giving it a capital letter, right, which just tells other people, hey, don't call this function unless you use the new keyword, because if you don't, we're going to attach properties to the global object. Okay, let's see now what strawberry, rhubarb, pumpkin, pecan is. I didn't use new. It is an object that has a single property called crust that is crusty. It's fun. Cool, any questions? So if I want to access it on the newly created object, which I have out here, I can say new pecan, pumpkin, whatever, dot crust, because that object just now has that property. And if I want to manipulate the object before it gets assigned to the variable, I can do it within the function itself. So this dot crust, I can say this dot. What else do pies have? Filling equals stuff, right? Cool, it has a crust and it has a filling, and if I access the crust, it's crusty. Cool. I could also take advantage of the fact that this is a function, and I could maybe actually pass the filling in when we create the new object. So right here, I'm creating the new pie. I could pass in, I'm just going to say this is the filling. And then right here, I'll say this dot filling equals filling. It should be starting to kind of look like the way you did things with classes, right? And that was the point of this. People wanted to feel like they were using classes, but we couldn't just add the class keyword into JavaScript, not back in old JavaScript anyway, not until ES6. So functions got abused, or used in this way. This is still what's going on under the hood. When you create classes, you just get this, you get a function. That's it. But now we get to call the functions a class instead of a, we get to use this word instead of the function word, whatever. But yeah, this is how I can create new objects that represent pies. Yay. Cool, any questions? Any experiment you want me to try with this? Any changes you'd like to make to the code we've got? Yeah, it would return what the function ordinarily undefines. This would be the global object. So if we actually checked the global object, let's do this. Let's make the mistake of not calling the function with new. Obviously, this will be undefined because that's how functions work. This is the global object. So the global object should have crust and filling. So let's console log the global object, which is spelled global in Node and is spelled window in the browser. See what happens. Boom. There is the global object that has a bunch of stuff on it, and there's crust and filling. So don't mess up and call a constructor function without new. That was kind of like a sidebar, though. If that didn't make sense, whatever. It doesn't. Not a big deal. Go ahead. Yeah, we didn't do anything with the first function. We just created a function. Can we extend functions? Absolutely, we can do anything. Okay, so here's my opinionated rant about this. We had JavaScript with plain old objects, just like we saw before the break, and that was good enough. We could do anything we wanted with it, and it was pretty simple. People weren't happy with that, so then we started using these constructor function things where you get this new keyword, and things got way too messy. It felt like we were in a programming language that had classes, but it was really messy, and when we try to extend something, it's not the nicest thing to have to do, and you're going to have to do that today, so you get a feel for that. So then people were like, you know what, we're kind of abusing these functions. Maybe we should stop using functions and use JavaScript the real way, the proper way, just use object literals. Obviously that didn't happen. People were like, let's introduce the class keyword to make it like easier and more like every other language. So now we have classes, and this is actually what's going on in the hood, and it's all kind of weird. And if you see prototypes in places like .prototype, it's a side effect of all of this. But yeah, you can definitely extend other functions. It's just the syntax is not nice using the constructor functions. Okay, cool. How are we doing? How's everyone feeling? Oh, how much time do we have left? Oh, we got a nice amount of time left. So, what's the next thing we want to do here? Yeah, okay. Let's answer this question now, because one more thing happens. These are the things that happen when we invoke it with the new operator. Function creates a new empty object. The new empty object is accessible inside this function using this. That object gets returned at the end of the function. So we've seen an example of how this works. One other thing happens. This object, this strawberry rhubarb pumpkin pecan pie in this case, gets a different prototype. So by default, objects prototype is object.prototype. But when you create an object using the construct function, it gets a different prototype. This object has a different prototype. What is this object's prototype? Who said pi? Like pi the function? Almost. It's not pi the function. What is this object's prototype? What is pi.prototype? Every function in JavaScript, every function, every single function, regardless of what you use it for, gets a property called prototype. So pi has a .prototype, baby pi has a .prototype. Any function you've ever created has a property called prototype. Why? Why does every function you ever create ever get a property called prototype, and what is this thing? Any ideas? Any guesses? When I console log this out, and I'm not going to console log this just to keep it clean, what do you think pi.prototype is? What do you think by default any function's .prototype is? What's inside the function? That'd be kind of a cool guess, right? Like maybe it consists of like crusts and fillings in this case. Playing the guess what .prototype is on functions.
Oh.
Yeah, we have a pie that has a crust that's crusty.
I guess.
Hey, okay, Joel. Every function has a property called prototype. What is that property?
I'm pretty sure that by itself it's just going to be an empty object.
Yeah, don't you love it when that happens? Like, what is this thing? Oh, it's an empty object. Just like in who are you waving at? No one waved back.
I'm waving at the future. Because eventually someone will watch this.
I don't know.
Hi, Dave.
Stop watching lectures. Hi.
You've all met Joel. I don't need to explain, right? Okay. It's an empty object. That was exciting, right? How much of the time in JavaScript is it just an empty object? Right? Like when you first looked at exports, and that was an empty object. Every function, every single function has a .prototype property that is an empty object. Why would this exist? Can you put stuff? Well, all right. How would I put stuff in an empty object? Okay, cool. It doesn't. That's not a bad guess, but it doesn't exist for that reason because we can access object.prototypes, methods and stuff without anything in the middle. It is this extra layer that gets added. If we have this empty object, we want to manipulate it anyway. I'm just going to add a property. pi.prototype.something equals something. Why not? Let's see. Right, I console logged before I set that, so of course it wouldn't appear in the console. Okay, now pi.prototype has something. Okay, so by default, the function, every single function has this. A .prototype property that is an empty object that we can manipulate. What is significant about that? And it has something to do with this line right here. What does that mean for us? Where? Where? Let's make this a little bit more, instead of grab them from the prototype object. That was vague enough for me to not say no. It's accessible on any function. So as soon as a function is created, let's say we have baby pi, it has a dot prototype, but yeah, pi dot prototype dot. So what do you mean, like this? How I'm doing it here, pi dot prototype dot something? Like not in a fancy way, but yeah, we could say like baby pi dot prototype dot something, oops, equals pi dot prototype dot.
Like, what I'm getting at is if it was specified all functions that save a bunch of stuff in the prototype object, and all functions.
Okay, that's kind of a fun way of thinking. What if all functions could end up having access to this thing? Well, how can we allow objects to be able to access properties of other objects? Through the prototype. So, first let's take a look at this. The object's prototype gets set to pi.prototype. So, what is console log strawberry. Oh, I haven't created it, that's why. There we go. What is strawberry, rhubarb, pumpkin, pecan's prototype? Something exists on the prototype, but what is the actual prototype? Pi.prototype. There we go. The object's prototype gets set to pi.prototype. So this pi's prototype is pi.prototype. This property should not be called prototype. It should be like prototype of objects created from this function. I think that's a better name. Catchy, right? If you create a new object using the new operator with this function, that object's prototype will be pi.prototype of object created. You know, it'll be pi.prototype. This isn't pi's prototype. It is the prototype of any object created using the new operator and pi. Yeah, wordy, right? What do you mean? Sure.
They're all different recipes. Would you be able to access all of those recipes from the prototype or just certain ones?
Good question. Well, since these all have the exact same prototype, what does that mean? If we asked strawberry or rhubarb or pumpkin or pecan for something, for some sort of property, I don't know, let's say we asked them for something. No pi has a something by default. We didn't give it a something. So the pi is going to do what it knows to do in JavaScript and ask its prototype. Any of the pi's prototype is pi.prototype. So we can attach a whole bunch of stuff to pi.prototype that any new object created from that function will be able to ask for, be able to borrow, be able to use.
So it's kind of like almost like a backdoor of other variables that we can add to like our new items or like our new.
Less of a backdoor. Yeah, kind of. It's kind of like prototypes. But yeah, let's go over this. So each one of these objects prototype will be pi.prototype, and let's make something a little bit more fun. Let's make it a method. So pi.prototype. Let's just get rid of some. Actually, let's make a new method. Pi.prototype. What should every pi be able to do? That will be the same, exact same for every single pi. It would be pointless to make this be eaten. Every pie should be able to be eaten. And what happens when you eat a pie? It's delicious. Nope. How do you, whatever. Let's That's why I use emojis. Is there a yum emoji? Yes, there is. Look at that. Okay, console log it's delicious, spelled incorrectly. So, none of the pies individually have this be eaten method, but their prototype does. So if I go to any of these pies, let's say pumpkin pecan, and I say be eaten, JavaScript's going to ask this pie, hey, do you have a be eaten method? Pie's going to go, no, I do not have a be eaten method, let me ask my prototype. Surely enough, its prototype, pie.prototype, does have the be eaten method. So if everything I've said is accurate so far, we should get true when we check to see if the pie's prototype is pie.prototype, and be eaten should work just fine for this object. It should say it's delicious. Let's try it. No pie.js. Whoops. I added, what line? 21. I added a thing on line 21, just to make it interesting. Boom. Now, let's take a look at an example of something else. We know we're passing in the filling to each thing, because every single pie might have a different filling. And maybe it'll have a different crust, but right now we're hard coding it, but we'll get to that later. Usually, the state of an object will be different for each object. So each pie might have a different filling. Each pie might have a different crust. Each pie might have a different whole bunch of other states. But every pie should be able to be eaten in the exact same way. So it makes sense for every single object to get its own state, because it's probably always going to be different. But when it comes to the behavior of that thing, well, why would we attach the behavior to each individual pie? That means we're just duplicating functions all over the place. If instead we put the function in a single object and have all of these objects linked to that object as its prototype, then if we call a method on any of the pies, it will just ask its prototype. So, not only that, we can also access this from within the prototype functions. So this inside this function is the current pie that it's being called on. So not only can I say it's delicious, I could also add a this.filling onto the end, so we can see which pie is getting eaten. Yeah, exactly. Well, yeah, down here. So like the pumpkin pecan is going to be eaten, and the rhubarb pumpkin pecan is going to be eaten. Be eaten. So now if we eat these two pies, we should see the standard behavior, but also it's going to use the state in some way. Kind of like classes. It's delicious, rhubarb pumpkin pecan and pumpkin pecan. Pecan. Yeah, it is behavior that every pie should be able to have when it needs to have it. But every pie shouldn't get its own version of that behavior. We just let all of the pies share that behavior.
So it's more of like a pool.
It's kind of like, kind of. The function is created on the prototype. Let's say I had 100 pies, but they all have a single prototype object. So one object is their prototype. Then, you know, at some point, if they need to perform some behavior that they can't do, they're just going to ask that single object, that single prototype. In this case, pie.prototype that will allow them to be eaten.
And that's just like kind of like generic behavior for this is before
Yeah.
it gets to null, it's just going to check that prototype by default.
Yeah, as long as we call a method on it. It's kind of like adding methods in the classes, right? That allows us to then call that method on an object later on if we need to. Okay, yeah, any questions about this so far? Okay, has anyone ever Googled how to use a method on an array like sort or for each or map or filter or reduce or yeah, everyone's head's nodding, yeah? Yeah, okay, so what did you do? You went to Google and you were like, what would I type in if I'm trying to figure out how to JavaScript, sure, that's a good start. Map. Yeah, that's probably good enough. JavaScript map. Okay, the first one is MDN. Is MDN good? Sweet. What is this to the left here? What is array.prototype? The hell is that? Everyone's seen that. Has anyone paid attention to that? Like, what is... Well, I asked for array.map, not array.prototype. Got it. Did anyone dive down the rabbit hole and figure out what array.prototype was? Maybe we know what it is. So first of all, before we look any further, what do we know about dot prototype? Yeah, so every time we create an array, but what do we know about dot prototype? And you just said it. Right, okay, so anything like dot prototype exists on functions. Every single function has dot prototype. What does that say about array with a capital A? It's a function. Let's see, let's check. Node, array. Wait, let's do type of array. Yeah, array is a function. That means that I can say array.prototype because I can do this with functions. Type. Cool, yeah. I don't think that exists. Yeah, because I haven't created it. If usually we create arrays this way, r equals array literal, and usually we create objects like this. But I can create an array, like this is just JavaScript shorthand syntax, which makes it a lot easier to write. This is actually a really nice thing that languages offer. I can create an array, the exact same array, empty array, using new array. The thing 3 lines above is just shorthand. So we know that array is a function. We know that it has a dot prototype, has a whole bunch of methods. We know that we can create a new array using new array. Similar to what we've already been doing. How do I create a new object? Like that's the shorthand, what's the longhand? So, yeah, absolutely. So what is object? And that's how object has a dot prototype. And that's why every time we create a new instance of object, whether we do it this way, the shorthand way, or the longhand way, that object's prototype will be the function's dot prototype. So every object's prototype will be object.prototype. Every array's prototype will be array.prototype. And we want them to be able to maintain their own state. We want arrays to have their own numbers. We want objects to be able to have their own properties. But they don't all need to have their own toString. Or in the array's case, they don't all need to have their own map, filter, reduce. So array.prototype is a single object in JavaScript that contains all of the methods you're probably going to need on an array. Then you create new instances of arrays. If you need to map, for each, filter, reduce, whatever, it doesn't have that method. It goes to its prototype. They all exist in one place, and it just uses that. So when we're looking at, well, how does map work? Map exists on array.prototype. So we have to look at array.prototype to see the map method. And here it is. And if I can actually get to, yeah, array.prototype right here. It'll give us every single method that you can call on an array. Because every array's prototype is array.prototype. So this is kind of cool. If we want to see what actually exists on an array by default, swipe left just to go back. So these are some things that actually exist on the array itself, not on the prototype. These are things that should be maybe different for each instance of an array. That is, from is array of, oh wait, no, these are class things. I meant to go up here. There aren't any. I thought, all right, it hasn't actually given them to me. But I'm pretty sure like array.length exists on each array individually, not on the function itself. The other thing was class. Ignore what I said 5 minutes ago. But yeah, so that's what dot prototype does. That's what constructor functions are. And that's why even if you were to see a class being made, say we create a class, I don't know what class, I need a really quick noun. turtle. Even if we created the class turtle that had a method that was like, I don't know, what do turtles do? Swim. Under the hood, this is just using that function syntax. So type of turtle will be function. Turtle will have a dot prototype because it is a function. And turtle dot prototype will have a method called swim. And if I create a new turtle, its prototype will be turtle.prototype, meaning that I can ask turt to swim. All make sense? Let's make sure Sam wasn't lying. Whoops. Damn it. I messed up my shortcuts. I don't want to console log that line. Cool. All right. I think that's good. Okay. Yeah, let's try that. There's no return on what? Oh, there's no return on swim. Yeah, let's return swam. Yeah. Turtles are cool like that. Node, what did I call this? Pi. Cool. So, I guess I didn't plug in my laptop. Got 5% left. Ah, I didn't flip the switch. So classes are actually just functions that act in this way. So if you ever see, things like .prototype, it's because of the way functions are used and abused in JavaScript with the new operator and the .prototype property, which is a useless property for every function to have, because if you don't use the function as a constructor function, it just has this empty object attached to it. Behind the scenes of the functions, it's just objects linked to other objects in a really, really simple way. The constructor functions make it more complicated. The classes make constructor functions less complicated, but nothing is as simple as like week 1 of bootcamp objects and functions, which is all that's going on behind the scenes. So any questions about anything to do with prototypes? It's just scratching the surface too. I feel like we could do a whole week on this. It'd be kind of fun, right? Because then we could start talking about like how does this work? Because who was upset that they had to use bind and that was weird this week, right? How does bind work? Why are we binding? But this is kind of just scratching the surface and all that. So fun stuff. Anything else you guys want to go over, or questions or anything? So I just like leave you alone and let you get to work. Does it matter if you use classes or constructor functions, or even the first way I showed you? Okay, here's a good line. It's kind of a glass half empty line, but there is no correct way to do object-oriented programming in JavaScript. Right. There is no correct way to do object-oriented programming in JavaScript. So if you use classes, you're not being correct. If you use the construct functions, you're not being correct. If you use object literals, it's not the correct way. There is no correct way. So I would guess like you could say any way is the correct way, but I prefer not to say it that way. The important thing is to be consistent. So if you're using classes or the rest of your team is using classes, just use classes. If you're programming in React, use classes because React's like all the documentation uses classes and they want you to use classes. If you're starting a new project and you want to use just object literals and like set prototypes manually, do it that way, but always do it that way. Don't switch between functions, classes, and the other way, because that will get messy quickly. But there's no correct way. There's no standard way. Class is the newest addition, but definitely not the correct way of doing it. Yeah. Okay. Today you're going to be working mainly with constructor functions, and I think you'll have to do even like a little bit of a inheritance thing that we didn't go over, but yeah, you'll be practicing this way mainly today. For what it's worth, every time I do object-oriented JavaScript, I do it that first way. I just create objects. Like if I want behavior, I create the object, add a method to it, and then like I'll create other objects that points that as its prototype. I'll never use classes or constructor functions if I can avoid it. Yeah. Cool. All right. Never know how to end a lecture. It's like goodbye. Or like if I had the microphone, I could drop the mic.